You remember when we talked about the body fluids or body fluid. Body fluids are present in two compartments, intracellular and extracellular. And inside the cells, 28 liters, and outside the cells, 40 liters. You see in this example, 42 liters. We said in the previous lecture, we said 45 liters, about 65% of the body weight. You see the extracellular, either in the interstitial spaces or as a plasma. Either the fluid in the extracellular compartment, either between cells or as a plasma. This figure or this table shows the composition of extracellular and intracellular fluid compartments. You see the extracellular fluid and intracellular fluid, and these are the contents. This is sodium, potassium, calcium, magnesium, chloride, etc. You see in the extracellular fluid mainly sodium, chloride, and proteins. You see there is no difference between plasma and interstitial fluid for the constituents. The same sodium, the same concentration of chloride, and even the same glucose and the same pH in both interstitial fluid and in plasma. The difference just the proteins in the plasma. You remember which produces the colloidal osmotic pressure. But when we compare the extracellular fluid and intracellular fluid, we'll see that sodium is little, but potassium, there is a big difference between intracellular and extracellular, and also sulfate and phosphate. And you see the intracellular proteins, 65, you see, compared to 16 in plasma. This is the difference between the constituents when we compare extracellular fluid and intracellular fluid. You see, there is no difference between interstitial fluid and plasma, even the glucose as well as the pH. You see distribution of water in various tissues and organs. Here, percent water. You see the highest you see in the blood. Then comes kidney, and the least adipose tissue. This is percent to body weight. You see, skin 18, muscle 42 about, skeleton 15. Liter in 70 kilogram man, you see in the skin 9, in the muscles 22, and in the blood you see 40, about 5 liters. Your total body water in relation to the age. You see the prime difference, the height difference between age 18 and 40, 10. Almost no difference between age 10 to 18, male compared to the female, just 2%. After age 40, the difference decreases, but not that much. Even over 60, the difference about 6%. percent. Now we see the water balance, which means that fluid intake should be equal to the fluid output. The fluid intake, you see, 2.2 liters as liquid and in food, and 400 ml from the metabolism. The total 2.6. How about the output? You see the output 500 expired in through the lungs, and 1.5 as urine, 450 through the skin, and 150 with the stool. The fluid output 2.6 is that the fluid intake is equal to the fluid output. This is the water balance between the fluid intake and fluid output. Now we see the defense of the body fluid volume. First condition, if increased sodium intake causes retention of water, increased blood volume. This stretches atria of the heart. Atrial natriuretic peptide increases sodium excretion, and reflexly ADH is inhibited. The result increased sodium and water excretion, restores body fluid volume. How about opposite? Decreased sodium intake causes excretion of water, decreased blood volume. What happens? Low pressure produces low pressure in the kidneys produces renin. This renin, a hormone produced by the kidneys. This renin produces angiotensin 1 from angiotensinogen plasma protein. Produces angiotensin 1, produces angiotensin 2 under the effect of enzyme or hormone from the lungs. And these are the function of angiotensin 2. Causes thirst, constricts blood vessels, stimulates ADH, and releases the aldosterone from the adrenal cortex glands. You see, ADH as well as aldosterone, they decrease sodium excretion and water excretion, then they restore the body fluid volume. This is the defense of the body against any change in the volume of the fluid. Let us have an idea about the dehydration. If the hemodynamic mechanism fails to operate properly, loss of fluid or electrolytes or both may occur. Three conditions may arise depending on the relative losses of fluid and electrolytes. You see, there are three types of dehydrations. First, isotonic dehydration, equal loss of fluid and electrolytes. Or hypertonic dehydration, excessive fluid loss as compared to electrolytes. And hypotonic dehydration, excessive electrolyte loss as compared to fluid. As you see, dehydration, three types. Clinical dehydration may be a consequence of either failure of absorption from alimentary tract or excessive loss from copious sweating, prolonged vomiting, diarrhea, and excessive diuresis, or drainage from wounds or veins. These are the clinical dehydration sequences. How about hydration? Hydration term referring to the result of excessive water intake or decreased loss of water or increased reabsorption of water from the kidney because of ADH administration. In such a case, the excess water is evenly distributed in both extracellular fluid and intracellular fluid compartment, causing an increased water volume with dilution of solutes in both areas. Excessive water intake may produce the syndrome of water intoxication, in which cellular function is disturbed by dilution of cellular electrolytes. Disorientation, convulsion, and coma may result, as well as gastrointestinal functions, muscular weakness, and abnormal cardiac rhythms. Let us have an idea about the lymphatic system. You see, this is the arterial end, and this is the venous end. In the arterial end, blood pressure 32 millimeter mercury, and colloidal osmotic pressure, if you remember, 28. And you see there is pressure, which is the plasma, to be filtrated from capillaries into interstitial spaces. And then plasma filtered containing little proteins. At the venous end, opposite. Blood pressure decreases, but plasma protein pressure does not change. There is osmosis. But not all the filtered plasma is retained to the venous end. Little plasma remains, also with little proteins. This remaining fluid is called lymph. It passes into the lymphatic system. You see, lymphatic system represent an accessory route through which fluid can flow from interstitial spaces into the blood. Lymph is a tissue fluid that enters lymphatic vessels, as we said. It drains into the venous blood via thoracic and right lymphatic duct. It contains clotting factors and clots in vitro, similar to the plasma, if you remember, but because it contains clotting factors. In most locations, there are proteins, but the concentration of these proteins varies according to the tissue. Water-insoluble fats are absorbed from the intestine into the lymphatics, and lymph in the thoracic duct after a meal is milky because of its high fat content. Lymphocytes enter circulation principally through the lymphatics, and there are appreciable numbers of lymphocytes in the thoracic duct lymph. The lymphatic system consists of lymphatic capillaries, lymphatic vessels, lymphatic nodes, as well as lymphatic ducts. And then these are the components of the lymphatic system. Lymphatic capillaries, lymphatic vessels, lymphatic ducts, and lymphatic nodes. Related organs, 3 organs closely related to the lymphatic system are spleen, tonsils, and thymus. All these organs are composed largely of lymphoid tissue, a specialized form of connective tissue characterized by a framework of reticular tissue and presence of lymphocytes. Tissues that lack lymphatic capillaries include avascular tissue, such as cartilage, the epidermis, and cornea of the eye. The central nervous system, portions of the spleen and bone marrow. And these organs, they don't have lymphatic capillaries. Flow of lymph. Lymph, like venous blood, is under relatively low pressure and may not flow readily through the lymphatic vessels without the aid of outside forces. These forces include contraction of skeletal muscles, pressure changes due to the action of breathing muscles, and contraction of smooth muscles in the walls of the larger lymphatics. These are the most important functions of the lymphatic system. You remember the retain of excess filtered fluid. We said at the venous end, the filtered fluid, some of the filtered fluid retains to the veins, some remains in the interstitial spaces and passes into the lymphatic system. This excess retains to the blood. Second, defense against diseases. The lymph percolates through the lymph nodes located en route within the lymphatic system. Passage of the fluid through the lymph node is an important aspect of the body's defense mechanism against disease. For example, bacteria picked up from the interstitial fluid are destroyed by special phagocyte cells located within the lymph nodes. 3. Transport of absorbed fat. You remember from the digestive system, and also we indicated within during the discussing of this lymphatic system. And returning of filtered protein. You remember some proteins remain in the interstitial spaces and passes into the lymphatic system. These proteins, they return back to the blood. Sometimes fluid remains in the interstitial spaces. This is called edema. Then edema is a condition caused by accumulation of fluid primarily in the interstitial compartment. Some factors are involved in the production of edema are presented, or we will present them. First, high capillary pressure. When there is high capillary pressure, a lot of fluid is filtered from capillaries into the interstitial spaces, and not the whole filtered fluid retained back into the venous end. 2. Low blood protein. The same as the venous end, not the whole fluid filtered retains to the veins. And 3. Lymphatic blockage. When there is blockage in the lymphatic system, the fluid accumulates in the interstitial spaces. Or increased capillary porosity. Almost, but the cause is different, similar to first, high capillary pressure. A lot of fluid is filtered from the capillaries into the interstitial spaces. Therefore, at venous end, not the whole fluid is retaining back into the veins and consequently into the blood. By this way, we have an idea about the blood groups, body fluids, as well as lymphatic system. I'm sorry, I don't like this way, because the best for the lecturing to face the students and to discuss the subject with the student. This way I don't like it at all. Anyway, but this is the wishes of my colleagues and other students. Thank you very much.